Welcome. In this lecture, we are going to discuss hazard analysis and critical control points. Hazard analysis and critical control points is one of the common food safety and quality system that is designed specifically to identify and control potential problems before they occur in food production. And the potential problems that can occur in food production are mainly the occurrence of food hazards. So, in other words, we can define hazard analysis and critical control point as a system designed to identify, evaluate, and control potential hazards before they occur in food production. And this system is mainly applied to ensure that the food products which are being produced meet the standards in terms of food safety management. This system is a preventive approach to food safety adopted by food industries and regulatory agencies across the globe because of its effectiveness. And it mainly deals with hazards that are significant for food safety. By this, I mean hazard analysis and critical control point deals with hazards that can cause adverse health effects or foodborne diseases. And then those other hazards which are not significant for food hazards are being covered under other food safety and quality systems such as prerequisite programs, which includes good agricultural practices, good hygienic practices, and good manufacturing practices. So, you will realize that the prerequisite programs mainly focus on the production environment, which may include the facility and then personal hygiene and so on. But the hazard analysis and critical control point primarily focuses on raw materials, products, and processes involved in the food product production. So having known or understand hazard analysis and critical control points, we can now look at some of the terms that we are going to use as we are studying hazard analysis and critical control points. And one of the definitions that we need to know is hazard. Hazard is any biological, chemical, or physical contamination that can cause foodborne illnesses. Or you can say it is any biological, chemical, or physical agent that can cause adverse health effects when consumed together with the food. Then the next term that we need to understand is hazard analysis. Hazard analysis is the process of collecting, evaluating information on hazards and conditions leading to their presence to decide which are significant for food safety and should be addressed in the hazard analysis and critical control point plan. This definition tells us that in hazard analysis, there are mainly four steps which are followed. And one of the steps, the first step which is followed is collecting information on hazards. After collecting the information of hazards, then the information which is collected on the hazard has to be evaluated. And then after evaluating the information on the hazards, then we need to understand the conditions leading to the occurrence of the hazards. Then after understanding the conditions, then we can now decide on significant hazards to be addressed in the hazard analysis and critical control point plan. So these four steps are the ones which we follow when we are doing hazard analysis. The next step is, the next term is critical control point. A critical control point is a food handling or preparation step where hazards can be prevented, eliminated, or reduced. So there are always steps where hazards can be prevented, eliminated, or reduced. And the application of this depends on the hazard which is present, because sometimes the hazard which is present may be the one which is not harmful, or the one which is not significant for food safety. So we can ignore it instead of preventing it. And sometimes, even if the hazard is for of significance for public health or food safety, it can be at a level that is acceptable, because it will be at a level which cannot cause adverse health effects to humans. But sometimes they can be at a level which are significant. So if they are at a level which is not accepted, we can either eliminate the hazard or reduce it to an acceptable level. So a critical control point is a food handling or preparation step where we can do all this. Then the next term is a critical limit. Critical limit is a criterion which separates acceptability from unacceptability. E.g., we can talk of the values of pH, which is acceptable or unacceptable, the value of water activity in the food, which is acceptable or not acceptable. Then we can talk of the value of temperature, which is acceptable or unacceptable, time, pressure, the concentration of pesticides, the concentration of mycotoxin like the aflatoxin, which might be acceptable or unacceptable, microbiological criteria, which may be acceptable or unacceptable. Can talk of the concentration of salts, colorants, stabilizers, flavorants, and so on. So when we say these are at acceptable level, that means they are at a level which cannot cause adverse health effect. But if they are unacceptable level, that means they are at a level that can cause adverse health effect or make the food unsafe. Acceptable, they are at a level which cannot make the food unsafe or cause adverse health effects. Unacceptable, at a level which can cause the food to be unsafe or cause adverse health effects on consumers. Then critical understanding this very important. And then the next term that we need to understand is a corrective actions. These are actions to be taken when the results of monitoring at the critical control point indicate a loss of control. So as you are monitoring the critical control point, you will realize that there are some point at CCP whereby there is a loss of control. So once you have realized that problem, you need to come up with measures in order to solve that problem at that time or in future. So at that time, if there's a problem, you need to come up with action or measures so that you can correct that problem so that the food remains safe for consumption. Monitoring, checking to use to see if the CCPs are being met. So that if they are not met, you go ahead and look for a corrective measure or you take a corrective action to take it back to the normal or to enable it meet the CCPs. Then risk, the probability or chances that a hazard will occur and cause harm. Then severity is the seriousness of the consequences of a hazard. Sometimes a hazard may be present in the food, and when it is consumed together with the food, it can cause a serious consequence on the human. And this type of hazards has to be eliminated or reduced at a level which is acceptable. But if the hazard in the food is not a serious one, then it can be not the one which can cause serious consequences on consumers, then it can be ignored. Now, understanding these terms is very, very important because we shall be using this term as we study hazard analysis and critical control points. So let us look at practical hazard analysis and critical control point principles. So the following are the principles that we need to put in our mind. That we always have to adapt the 7 hazard analysis and critical control point steps into a form easily applied in a non-commercial setting. This is because these hazard analysis and critical control points are not necessarily important to commercial settings only, but they are also very important for non-commercial settings, and therefore we have to always adapt it in a way that uh, the steps can also be applied in a non-commercial setting. Then the hazard analysis and critical control point should focus on the issues of thorough cooking and cooling, which are the major causes of foodborne illnesses, must be developed and adhered to with standard operating procedures of personal hygiene, basic sanitation, and food storage. So as we are developing and implementing the hazard analysis and critical control point, we have to do it in a way that it has to be done with standard operating procedures of personal hygiene, basic sanitation, and food storage. So now we can look at the formal hazard analysis and critical control point 7 steps, which are also referred to as the universal steps in conducting hazard analysis and critical control points. And understanding this will help us to apply these steps even in non-commercial settings in a practical manner. So the first step is conduct a hazard analysis. And by this we mean you have to identify the hazards that could occur at each step of food preparation. So before you start implementing or following the procedures in this system, the first thing you need to understand or do is you have to identify the hazards that which could occur at each of the step of food preparation. And you can do that by preparing a process flow chart diagram which covers all the steps from receipt of raw materials to dispatch of finished products. And then after after you preparing the process flow diagram, it will help you to identify the likely hazards at every process step. Then after you identifying the hazards at every step, then you go ahead and describe the measures for controlling those hazards at each step. After doing that, you can now proceed to the second step, whereby you are going to determine the critical control points. And by this we mean you identify the steps to to prevent, eliminate, or reduce hazards to acceptable level. So you can achieve that in this step by analyzing each step using the hazard analysis and critical control point decision tree, because using this decision tree can help you to identify these hazards with ease and then analyze them with ease. Then after doing that, you identify the steps in the decision tree or the points in the decision tree where control is very critical or very important for assuring the safety of the food product. After doing that, after determining the critical control point, then you can now move to the next step in which you will establish critical limits. By establishing critical limit, we mean you set specific criteria for each critical control point that must be met to ensure food safety. So in the second step, you have determined the critical points at each step. So after that, in the next step, you now have to set specific criteria for each of the critical control points that must be met in order for you to ensure food safety. And you can do that by fixing critical limit for control measures relating to each identified critical control points, e.g., temperature, time, speed, pH, and water activity, or what we call moisture content of the food. After establishing these critical limits at each critical control points, you can now establish monitoring procedures. And here you are going to monitor each critical control point to ensure that the critical limits are being met. You monitor each critical control point to ensure that the critical limits are being met. And here you are going to decide on the monitoring procedure, which should cover the nature of monitoring, which can be through observation or testing. And also you decide on monitoring frequency and responsibilities for monitoring and recording monitoring results. So after you now monitoring each critical control point to ensure that the critical limits are met, you now go ahead and establish corrective actions. By this we mean you need to have a plan for what to do if a critical control point is not met. Remember, in step 4, you were establishing a monitoring procedure whereby you were monitoring each of the critical control points to ensure that the critical limits are being met. So now if you have realized that uh, the critical control points are not being met at any of the critical control point, then you go ahead and establish a corrective action. This means that you need to develop procedures for dealing with the deviation from the critical limits, which when it occurs, and how to bring the critical control point back into control. So you have realized a deviation from this step as you were monitoring. You have realized a deviation from the critical limits. Therefore, in the next step, step number 5, you need to look for ways of how you can bring the critical control point back into control. And that is what establishing corrective action entails. And this may include disposition of the affected product produced during deviation, because you already know that the product that has been produced during the deviation is the one which is unsafe. So you need to dispose it so that it doesn't cause adverse health effect to humans when it is consumed. Instead of distributing it, you dispose it. Then the next step after establishing a corrective action is you need to establish a verification procedure. That means you need to verify that the hazard analysis and critical control points plan is working as intended. Because before you start to follow the procedures, you need to say the first plan. So you are implementing the procedures, you need to always verify whether it is working as you have planned or not. So here you make sure that you develop procedures for verification to confirm that the hazard analysis and critical control point plan is working. And you can do that by taking, for instance, doing periodic audit, random sampling and analysis, or review of the hazard analysis and critical point system and its records. Then after you verifying that the hazard analysis and critical control point plan is working as intended, you can now move to the last step, in which you will establish record keeping and documentation procedures. Here, you are going to keep records of all monitoring and corrective actions. And you can do that by preparing and following procedures and work instructions for each control measures, including those needed for maintaining hygienic condition, and then you have to keep record of the procedures and those instructions. And now, when that is done, then the food product stands a higher chances of being safe during the time of processing or production. So having known these formal 7 steps of hazard analysis and critical control points, then we can look at how we can apply these formal steps in a practical setting or in a non-commercial setting. Uh, these steps are simply follows the ones in the formal. We are just applying the knowledge that we have got in the formal to a practical situation. So, in the first step, in a practical setting, we can review the menu and highlight potential hazardous foods. This is because you have a list of menu, uh, including all the ingredients. So you have to identify the foods on your menu most likely to cause foodborne diseases if not handled properly. Then after identifying those foods, you have to go back and review the receipts that includes the potentially hazardous foods which you have identified here. Then and you have to highlight the problem ingredients so that you can identify the steps in your recipes where hazards could occur because you know which recipe or which food is having hazard, is having a high potential for of hazard. Therefore, you will be in position of knowing which steps, in which step is the hazard most likely going to occur. Then after identifying the steps in your receipts where hazards could occur, you can now go ahead and include critical temperatures and times in the receipt and procedures. As you have the procedures already, and now you have identified the food uh, which are most likely to cause foodborne diseases, and also you have also identified the steps in your receipt where hazards could occur. Then that means you can now go ahead and set critical temperatures or include the critical times in the receipt or procedure that you are going to follow. And we are advised to always use the critical temperature and times established by the USDA to cook and cool food safely. Then from there, you can move to the next step, whereby you now check the food temperatures during preparation, holding, cooking, and cooling. And we can check this temperature by using food thermometer, especially the probe thermometer, because it is having a pointed and metallic tip. But always ensure that this thermometer is sanitized to avoid cross contamination. And you are going to use this thermometer to check the temperature of food at critical points in the preparation process so that you can monitor if the temperature is exceeding the critical limit or not, or it has not reached to the critical limit or not, so that if there is a deviation you can easily correct. Then in the next step, you can correct if required temperature are not being met. That's what I was saying. If the critical limit is being exceeded or it has not reached to the temperature has not reached to the critical limit, then you have to come up with a corrective action. You take a corrective action in order to correct that problem or to ensure that the food is not cooked or cooled to the at an appropriate temperature. And then after taking the corrective action, you can now go ahead and verify that the previous steps are being followed according to the way it has been planned. And you can do that by observation, and you have to observe and document that all of the steps in your hazard analysis and critical control point plan are being followed as it has been planned. Then after verifying, you can go ahead and now record time and temperatures. Keep records of the time and temperature of the food during preparation, cooking, and cooling. And that is how we can apply this formal hazard analysis and critical control point 7 steps in a non-commercial setting or in a practical way. Then having known the 7 steps, we can now go ahead and discuss about the hazard analysis and critical control point plan. The hazard analysis and critical control point plan is the documentation that shows how significant hazards will be controlled. Remember, we said during hazard analysis, you are collecting information about the hazards, then you are evaluating this information, then you are after evaluating this information, you are going to understand the condition which leads to these hazards, and then lastly, then you decide which hazard is significant to food safety, so that it will help you to decide which one are you going to control or address in the hazard analysis and critical control point plan. Okay, so uh, the hazard analysis and critical control point plan is just a document that shows how significant hazard will be controlled, the one which they are significant to food hazard are being controlled, and therefore it indicates what needs to be done, when should it be done, where should it be done, and it should be done by who is going to do it. And these these hazard analysis and critical control point plan consists of the following. One, it is made up of what we call a core plan, and this core plan involves a valid process flow chart, flow diagram or flow chart. And of course, it has to be valid because it has to clearly show the procedures that will be followed without any problem. Because if there's a mess here, that means the product which is going to be produced is most likely going to be unsafe. Then it is also made up of documented critical control point management details. And these details, management details, can be captured in a hazard analysis and critical control point control chart, or it can be captured in critical control point management table. So in the core plan, we mainly have these two: valid process flow diagram and then documented critical control point management details. Then the next component of the core plan the next component of the hazard analysis and critical control point plan is a support document. And this support document comprises of the preparatory documentation that has been used in developing the hazard analysis and critical control point plan. And also, it has the details of the verification requirements. Then this includes the hazard analysis critical control point team details, which members are found in this team. Take for instance the food technologist, you can find the supervisors of the assurance team, transportation, and so on. So the support document has also got the details of the hazard analysis and critical control point team. Then it also has products or process description, how it describe about the product and also the processes which are being followed in the, producing the products, or how the process is being done. Then it also has information on hazard analysis details. Then also it has critical control point identification, hazard analysis and critical control point verification plan. Then also it has hazard analysis and critical control point audit and review data. Then it also contain the documenting the hazard analysis and critical control point study, and then also it involves hazard analysis and critical control point plan development. So this supportive document is very important because it actually is the one which contains most of the information uh, concerning the hazard analysis and critical control point which is being applied. So knowing this is very important because that means as you are planning, you have to include all this information in your plan, and it has to be there in your record for future references. Then having known the hazard analysis and critical control point plan, we can now look at how can we implement the hazard analysis and critical control point plan. So this is very important because knowing this will help you to conduct a hazard analysis and critical control point. If you don't understand or you don't know these steps, you will fail to conduct uh, hazard analysis critical control point, and that will be very dangerous because you are most likely going to come up with a product which may be rejected, or if accepted can cause adverse health effect to consumers. So the steps which we follow, or the steps which are involved in developing and implementing a hazard analysis and critical control point plan, are the following. First step, that is a assemble hazard analysis and critical control point team. So this first step is a preparatory step. Mainly, these the steps which are followed in implementing the hazard analysis and critical control point plan are 12 in number. And out of these 12 steps, the first 5 steps are referred to as preparatory steps. Then the last 7 steps are referred to as the universal steps, which we have already looked at when we were talking about the formal hazard analysis and critical control point 7 steps. So the first step, which is among us the first 5 steps, is assemble the hazard analysis and critical control point team. And by this we mean you have to first of all appoint a multidisciplinary team with a hazard analysis and critical control point coordinator to coordinate these team members. And this multidisciplinary team can comprise of food technologists, microbiologists, and then the supervisors of the following sectors. quality assurance, engineering, purchasing, production, and maintenance. So always when we want to implement this system or the hazard analysis and critical control point plan, we have to always make sure we first assemble this team, because without this team there's nothing which can be done, because they are the ones which are involved in implementing this process. Then after assembling the team, you can now describe the product, the second step, which is also a preparatory step. So uh, you need to describe the product, and when you are describing the product, you put into consideration the composition of the product. That's say the ingredients which are included in the product has to be clearly stipulated. And of course, this is very important because it will help to guide consumers, because some of them may be allergic to some of the ingredients. So you have to describe it very well. And then it also help to guide the people who are involved in executing the procedures, so that they know which ingredient is having hazards, which ingredient is more vulnerable to hazards and which ones are not. Then also, when you are describing the product, you need to describe its structure. Is it going to be in a liquid form, powdered form, or in a solid form? Then also you need to talk about the processing conditions of the product. Does it require heat treatment, freezing, or brining? Then also you describe the packaging uh, material, or is it going to be in a bottle or in a packet, or it is going to be contained in bags. Then you also describe the storage condition, because is it ambient temperature, refrigeration, or freezing. Then also talk about how can the product be distributed. That is say the transportation condition. Does it require a refrigerator, or it is going to be ambient temperature? And then also you need to describe the shelf life of the product, because it's very important. If the shelf life is not known, that means consumers may end up uh, feeding or consuming products which are expired and hence having no nutrients. So the next step that we follow when we are implementing the HAS plan is you need to identify the intended use of the product. By this we mean you need to describe the expected use of the product and by whom. The use of the product and who is going to use the product. Is the product going to be used by the end users, like in the restaurant, food processor, retailer, or consumers? And if it is being used, is going to be used by consumers, which category of individual? Is it going to be used by adults, children, the elderly, or patients in the hospital, or pregnant women? Has to be clearly specified so that people will know and it will help to guide them. Then also you need to describe whether the product should be consumed as is drained or cooked, and if it is cooked, should it be fried, baked, or steamed or not? So this is a very important for the consumers and also the people who are involved in the process of developing or producing the product. Then the fourth step, which is also still one of the preparatory steps, is you have to construct flow diagram. By this we mean you need to prepare a detailed process flow diagram or diagram showing each step in the operation, from receipt of raw materials up to defined end use. And Of course, there are a lot of processes which are involved in between the receipt of raw materials and defined end use. It involves storage, processing, and then transportation, and so on. So you need to make sure that your flow diagram shows all these steps, and the flow chart should also indicate the time and temperature requirements at each step. Product recycle or rework loops should also contain equipment layout, personal routes, water and water flow, then waste flow. All has to be included. This water flow and waste flow is very important because it helps to prevent cross contamination, because they have to flow in a different ways. And you know to know how to design that. Then the fifth step, which is the last preparatory step in the implementation of hazard analysis and critical control point plan, is on-site confirmation of flow diagram. So after you constructing a flow diagram, then you need to observe the actual operations during the normal working days. It can be at night, weekend, and confirm or amend the flow diagram to reflect the actual steps. So in step number 4, you have just constructed the flow diagram. So you now need to uh, observe whether the procedures which are shown in the flow diagram is followed as it is shown on the chart, or there are problems with the flow chart, so that if there is a problem with the flow diagram, then you can go and amend those changes to reflect the actual steps which are being followed. Because sometimes when you draw the flow chart and it has not been applied or done practically, there may be other errors or weaknesses, or what you have drawn may practically be impossible. So if such kind of things happen, you need to go back and amend the flow diagram so that it reflects the actual steps to be followed. And you can ensure you can realize this only when you observe the actual operation, be it during the normal working hours, during night shift, weekend, so on. So you have to monitor. Then after going through these preparatory steps, let's say from step number 1 up to step number 5, you move to the first universal step, that is being developed by the codex, and it is following the principles. Have the first principle of hazard analysis and critical control point, and here now it is the sixth step in implementing the hazard analysis and critical control point plan. So this sixth step entails that you have to list all the potential hazards associated with each step, then conduct a hazard analysis and consider any measure to control the hazards. We have talked more on this. You can refer to the 7 steps of hazard analysis and critical control points that we have looked at. So say the first, you need to identify the potential hazards associated at each step, and then you conduct the hazard analysis. We know how to conduct it, and then you consider any measure which can be put in place to control the hazards. Then the next step, which is step number 7, you determine critical control points, and this is the principle number 2, which we have already looked at. Then the next step is you establish critical limits for each critical control point, and this is principle number 3 when we are looking at the steps. Then from there, after establishing critical limits for each critical control point, you establish a monitoring system for each critical control point, and this is a principle number 7. Then step number 10 in the implementation of the hazard analysis and critical control point plan is establishing corrective actions. Then from there, you can go ahead and establish verification procedures, which we have named it as principle number 6 when we are looking at the steps of hazard. Then the last step that you follow during the implementation of the hazard analysis and critical control point plan is establishing documentation and record keeping. And we emphasize more on this, its importance and what you are supposed to do when we are discussing about the principles of hazard analysis and critical control point, or the steps followed when we are conducting hazard analysis and critical control point. So these 12 are basically the steps that we need to always follow whenever we are implementing the hazard analysis and critical control point plans. And as we discussed earlier on, that out of these 12 steps, the first 5 steps, let's say step number 1 to step number 5, we call them preparatory steps. And then the last 7, let's say from step number 6 to 12, we call them the universal principles. So make sure you always follow this whenever you want to implement hazard analysis and critical control point plan. And with this, we have come to the end of our lecture. I thank you for your audience, and we catch up in our next lecture. Thanks.